Hi guys, let's continue solving our task, and today we have the following one. So we have task that's called remove outermost parentheses. Okay, so let's go with our algorithm. So first we read and try to understand the question. Okay, we have a definition of valid parentheses. So it was an empty string, parentheses that open and close, or open close under. Yeah, so or this one is also valid one. This one is also valid one. A valid parenthesis string is a primitive if it's non-empty. Okay, I think this one is very, very important. And there doesn't exist a way to split it into S plus A plus B, where with A and B non-empty valid parenthesis string. So we are given a valid parenthesis string and consider its primitive decomposition, where PI are primitive valid parenthesis strings. We have to return S after removing the outermost parentheses of every primitive string in the primitive decomposition of S. Great. So I think it's very, very good question. So our task is to remove outermost parentheses. Understanding. I think with this one, it's finished. Let's check some test cases that we can have. So if we have empty string, then the result would be also empty string. If we have parentheses like this, result would be also the parentheses like this. If we have parentheses like this as well, we have by definition of value of primitive, we have this. But when we have something like this, it means that we have outermost parentheses and we have to remove it actually from our string. And as well, if we have something like this, we also should remove it and we should have this kind of parentheses. Okay. Let's think about solutions. And I expect as well, constraints. So like 2.2 constraints. So by constraints, I mean we have a string with length of 2, and here, let's say 1000. All right, so we have understanding test cases, constraints. So think about solutions. So what can we do? Let's take some example with parentheses. So when we put our parentheses, right? When we put our parentheses, so usually I think here we can use a stack. So we can put an open parenthesis, and then, for example, we have closing one. But how can we know how much of values it's already closed? Maybe we can store not only open parentheses, but we are storing open, but we are storing maybe indexes. So for example, we store 0, then we have another open, we store 1, then we have closing 2, right? we have closing 2. So it means that 2 minus 1 is equal to 1. So I can take it. Then I have open 0, 1, 2, 3. And open 4. And after this, yeah, let's first figure out how it should look like. So it should look like something like this, I believe. Correct. Mm-hmm. Yes, like this. So if we take a look here, so we have 3, and then we have this kind of values. Okay, so regarding our, so we put 3, then 0, 1, 2, 3, then 4, then I have 5, right? 5. So I remove these 4, and then I have 6, and so if I have 6, but I still have something here, right? I still have something in my stack. Yeah, I think that in this case I can remove. Then I have another close, and now this 0 I should not remove, right? Mm-hmm. Okay, and yeah, and when I have another one, I can have like a set to remove. And when I have like empty stack and closing one, I should put into my set to remove this start and position. Okay, yeah, I think this solution works, and the time complexity would be of n, and space would be also of n because of stack and offset. Okay, so let's try to implement. So we have our string result, we return our result, then we have our stack of string stack, new stack. Okay. Yeah, what next? We put into our stack. No, we can do like this, like while, or even not while, like for int I 0 I less than s x I plus plus, then I take character from s char at I. So if it's character, then I'll do something like this. And if my stack is empty, I also have a set of integer to remove, new hash set. Okay, and yeah, and here stack is empty, then I just do like stack put I, else stack is not empty. What should I do here? Yeah, stack is empty, or C equal to open parenthesis. Yeah, so I always put open. So now it's closed. Else, if stack size equal to 1, else I just stack pop, and that's it. Otherwise, I have stack size equal to 1, and I have closing parentheses now. Yeah, in this case, I should check like stack pop start, and if I minus start is greater than 1, then I put into my set I and also start. So I put these two elements that I should remove from my result. Then at the end, I just iterating through my these characters, right? So char integer the same thing. Here also I'm taking character, and here I check if if to remove contains C, not C but I. If it not contains, then result plus C. Yes, and return result. Let's check. All right, stack add I, stack add stack should add integer as well. Stack, size pop, Okay, this one works. This one works, but this one doesn't work. Output. All right. Okay, so probably I need to just remove this if. Let's submit. Okay, and we see that it accepted. Let's check editorial. There is no editorial. Let's check solutions. And first description. So first hint, can you find primitive decomposition? The number of open and closed curly must be equal. Okay. Okay. Let's check solutions. Open and plus plus, close minus minus. And in this case, we just increment opened. So if it's open and open is more than 0, I append and increment opened. And then again, I increment, and then decrement. Yeah, I think this one is really, really cool. Let's check my submissions. For example, here. Here. Yeah. Yeah, so my submission is similar. I think here as well, like stack. We can use stack. Yeah, I think it's more complex with this one. Yeah, but this solution is much more better. Cool. Another one. Yeah, the same. All right, so that's it. Thank you very much.